So this is part 2 of the Chapter 8 lecture, and I think I left off with talking about constructors. It is possible to have more than one constructor that you have written, a custom constructor or 2 or 3, in addition to the default constructor that's always provided for you. So you can have multiple constructors so that you can initialize the instance variables in different ways. That's not unusual. And remember that constructors are public. It doesn't really do us any good to have private constructors at this point, so all of our constructors will have a visibility or scope or an access modifier of public. So let's talk a little bit more about methods and variables. So most of the methods we've written so far have been public, just like our getters and setters. Public methods can be used anywhere, so you can use them in main, so you can use object name like Stevie dot set age, for example, or you can use them in other class files that are in your project. Public methods are accessible to all client programs. That's another way of saying this. So when we say client programs, we mean other programs running in the compiler or other programs running on the computer, presumably Java programs in this case. So those public methods are accessible to programs that are running on your computer, or public methods are accessible to all client programs. That's a common phrase that you'll see. If you make a method private, it can only be called or used within the class file, in the class file where it's declared. So a method in that class file can call it, but you can't use it in main, and you can't use it in any other. You can't call it from any other class file. So occasionally we'll have maybe some helper methods that are private, but most of our methods are going to be public. Now we do keep private variables in our code because we make all of our instance variables private, and we know that they cannot be directly manipulated, accessed, or changed within main or anywhere else. We can only manipulate them through our public getter and setter methods in the class. So if you have an instance variable, you can directly manipulate it or change it within any method in the class file where it's declared, but that's the only way you can directly manipulate it. Otherwise you have to use a setter or getter method to access it or manipulate it. Now, Chapter 8 deals a lot with the word static, and we've seen the word static before because we can declare constants like, say, pi with the word static, but there are other uses for the word static as well. We can have static variables, and that means that variable only gets created one time in memory, no matter how many objects of that class you create. A static variable only gets created once in memory, and it holds a value that's the same for all the objects. So if I'm counting the number of bicycles objects that I've created, I can have a static variable number of bicycles. There'll only be one integer declared in memory, and every time I create a new object I can bump up the value in that, and no matter which object I use to get number of bicycles, I'm going to get the total that's being accumulated in that one memory location. So static variables have a single value and they apply to the whole class rather than there being one for each individual object. And so that means if one object updates the value in that static variable, it's updated for every object. So now every object will reflect the new change or update. So we can have static variables, we can use the word static to declare constants like pi, or we can have static methods. So we can do public static, void, something or other. So static methods, just like static variables, they work for the entire class. They perform an operation for the entire class, not just on each individual object. So static methods generally do not manipulate or use instance variables. They are generally referencing static variables when you use them. And of course, static final, those are the keywords to set up constants. Sometimes you declare those as public, sometimes as private. Now the AP Java subset only deals with the words public and private when it comes to access modifiers or scope or visibility. So the Java subset on the AP exam will only reference public and private. There is another modifier type called protected, and I think there's one called package. Those two are not part of the AP Java subset. So if you have a quiz question that says protected variables are part of the AP Java subset, that's false. Only public and private methods and variables are in the AP Java subset. And the main method will always be static. That way we don't have to create an object of the type main in order to run our code. That's why it's static. So static versus instance. Instant methods operate on individual objects of the class, and those are our getters and our setters, and all the methods we've written so far have primarily been instance method. They work on instance variables, and they manipulate the individual instance variables for the individual objects. So I can set the name for my Stevie dog object to Stevie. I can set the name for my Coco dog object to Coco by using instance variables and instance methods that set the unique values in memory for each object. Now static methods, again, work for the whole class. They tend to work with static variables, not instance variables. You'll see them a lot used as accumulators or keeping running totals. They operate for the entire class. Now, when the AP subset, again, I want to make sure you understand, in the AP subset, we talk about visibility. We're talking about scope, access modifiers, visibility. Those are all terms for the same thing. Where can a variable or method be used? Where can it be seen? Like main versus just in the individual class file itself. So in the AP Java subset, all classes will be public. All instance variables will be private. Methods, constructors, and constants can be either public or private. The AP Java subset does not use the protected or package visibility. And again, just visibility and scope are the same thing. Now, the last thing I'm going to talk about really quickly here, actual versus formal parameters, and I got this off of a website. I'll give you the URL shortly. When you are calling a method and you're passing either a value like 5 or quote Stevie quote, or you're using a variable in the method call, so say this is in main and I'm calling the method add, for example. The parameters here, number 1 and number 2, are called actual parameters. They're also called arguments. When I get into my class file and I'm looking at the method and I have the parameter list here, where I'm going to send a copy of whatever is in number 1 and it's going to get assigned to X, and I'm going to send a copy of what's in number 2, it's going to get assigned to Y. Those are formal parameters, so you need to understand or at least memorize the terminology. In the method call, they're called actual parameters. In the actual method header, they are formal parameters. And this is a pretty good website for lots of information on Java and other languages, and it has some really good visuals on there. So what is passed to a method is an argument or actual parameter, and then the type of data the method takes in its method header is it's also called a parameter or a formal parameter. So the variable names can be different, and that's okay. So they were passed as actual parameters, number 1 and number 2, they're renamed X and Y as formal parameters. And they are passed as copies. So whatever's in number 1 is copied and put temporarily into a memory location that's created named X. Whatever is in number 2 is copied and put into a memory location that's created just long enough for the method to run named Y. When X and Y are used and this method is done, X and Y are destroyed. The copies of those variables are destroyed. Number 1 and number 2 still exist, at least if they're in main. What that means is if you change the value of X and Y here in the add method, it does not change their value back in main. And if you look on this link, mathbits.com, the Java section of that website. It has some really good examples that walk you through how that works. And finally, pass by value means that when a method is called, a copy of that is passed to the method. The copy, just what I just said, the copy can be changed inside the method, but that does not change it back in main. So when we are calling, we are passing by value. We're making a copy. The copy lives just long enough for the method to run, then it's destroyed. And any changes to X and Y do not update number 1 and number 2.